Subtract this. Subtract 10. And I did have on the side, please go ahead and do this for help.
Now, I hope I have that copied down correctly. If I did not have on the side to let you represent something, I guarantee I've got students in this class, quite a few students, who probably could say, Professor, I might be able to try something without this to get the answers. And guys, tell me what that might be that we actually looked at before in this class that you might apply if you did not want to use the strategy, let you be something. There we go. You can't factor it, not this. Something else that we've done actually in this class. It will be a little lengthy, but it will work. What do you think it is? Now it says find, they say find the zeros. In other words, solve it. Find, they call it zeros. Find the zeros, find the answer. I think I heard someone say something. Quadratic formula. If, by the way, it's not quadratic right now. There you go. I will definitely make it a quadratic. That's why I'm saying let you be something here shortly. But let's say you did not have that, let you be something. What other strategy could you use in an attempt to solve it? Here we go. Okay, hang on now. So you say move the 10 to the other side. In other words, they want you to do this. I think it's a good problem to look at. Because if most of my students would say, Professor, if I solve this and you did not give me this, you didn't say solve it like this, I'm hearing move the 10 to the other side.
And then times 3x plus 13 root x.
Something else I was thinking of. Something else that maybe we have actually seen in this class. I know it looks a little strange here that we've actually done in this class that I think we'll leave it to the answers. Might be a little lengthy though. Yes?
Multiply everything by x.
I love this input. Something that we've done, not yet. No, not that.
Plus b divided by 2 square.
What? B divided by something squared. Not quite. I got you. I know exactly where you're going. Not there. And you'll see why we appreciate let you be something here shortly. Why we appreciate that strategy coming up. I'm going to do it by another strategy we've seen in this class. Yes?
I'm assuming you want to get rid of the square root.
Thank you. Show me more.
So you would probably want to square both sides.
Yeah, but I don't think I want to square both sides right now. What would you suggest I do? I am going to square both sides because I need to eliminate that square root. But I don't think I want to square both sides the way it looks right now. Unless you want to. Yes?
Can you just let you to square?
I am. I'm going to do that shortly. Not yet though. I want to redo it, doing this, and show you and let you get an appreciation of how much help this is compared to what we're going to do. Who has an idea?
Complete the square?
Do it again.
Complete the square?
Oh, I can't complete the square on this. It's not a quadratic. Not a quadratic. Yes.
Divide by 3x minus 13.
Divide by 3x minus 13. Can't do that. Oh, I'm glad I brought this in.
Maybe times 3x plus 13.
No. Look at it. And your instructor, your textbook, your whoever, did not give you this to do, which we're going to use. You will appreciate this when I redo it. No, but suppose you did not have that and say, hey, solve this. Because you go to UCLA, they're not going to put this on the side. They'll just assume you'll do it. But what else could I have done here? Now, I'm hearing you better get rid of that square root, Professor. Give me again.
Before you have to get rid of the square root, you got to get rid of the minus 13.
Okay, hang on. So you're telling me, let's do this. Should I isolate it by itself, the term that has the square root in it? On one side, all by itself. Now you start moving things around. Guys, I think the best thing to do for here is to move this term over to the left. It becomes positive. Just moving terms around. And move this 10 over here. Just moving terms around. Let me step back and look at it. Do I at least have a term that has the square root in it isolated? Now, the question was, or the remark was,
get rid of that square root, Professor. Now, can I now use something we've used in class? Yes?
Maybe divide each side by,
I know 13, I know, divide by 13, which is gonna be awkward as you know what, but I could. What else can I do?
Maybe times x both sides.
No, something else. Square both sides. At least the square root's isolated, so you may say, Professor, I don't want to divide by 13, get a 13 underneath here. Which you could though. You may say, can I go ahead and do this? Oh my goodness. Now this, 13 squared is 169. 13 times 13. Square root x squared, yes, that does eliminate that square root. So this is 169x. Are you kidding? This, somebody in this accelerated class, tell me, what is 3x subtract 10 times 3x subtract 10? What would that give you?
9,
You have to expand it out. What is it?
9 squared
9x squared I'll take. I hear 9x squared.
minus 60x
Whoa, 60x. And,
600.
oh, that's exactly what you would get. You multiply that out or expand out that side. Now, by the way, is the square root gone? Yes. Do I now have a quadratic? Strange looking quadratic, but I have it. So let's move everything to one side. If one side 0, guys, I've got such strange numbers. Look at this. This is going to be 9x squared. I'm moving this over. Join that one. Make sure I get one side to be 0. 169 and a negative 60. Look at this math. What is 169 and a 60? Help me out. It's 2 something. 229? 229? That's minus. I just want you to get an appreciation here. And of course, I still have the 100. Jeez, let me step back and look at that. This is a quadratic. Now, you guys who were at first saying, Professor, complete the square. That would be madness. Try to complete the square on that one. But you could. Some students say, Professor, can you factor this? I have no idea. I haven't tried yet. It's strange. Could I use a quadratic formula, Professor? You can use any of those methods if you have the patience and the time. Any of those methods on this and get the answers for X. Does everyone agree with these big numbers? It's going to be awkward as you know what? It may factor. I don't know how strong my factoring skills might be. I don't know, but I may have a student out there that say, Professor, wait, I think I know how to factor that. Does anyone think they know how to factor that strange 9x squared business? Well, I surely don't. You can try something. What do you want to try? We'll try 3x and 3x? Or 9x and 1x? What do you think?
9x plus 4
Whoa. 9x
plus,
and x. You want plus 4 here?
yeah,
Okay, PK, plus 4.
and minus 25.
25?
Yeah.
Hang on. Oh my goodness, let's see if she's got it. This is 4x. This is madness. It's negative, I guess, 225. I think. Is it, guys? Was this a negative,
Negative 4.
negative 4 here?
Yeah.
Now, will that give me a negative 4x? Now, will these two put together, put x there, will these put together give me that negative 229 I want? Are you kidding? PK, congratulations. Now, all she would do now is she'd say, wait, Professor, I have it. Make sure I copy her beautiful work down correctly. Professor, you're saying when you split this up, you are now considering for this strange problem 25, and it looks like might be 4/9. If I did all that correctly. Is it? Are those the answers coming out? I see some looks like, oh no, Professor, you would not do that to us, would you? not do that to us, would you, Professor? Unless you let PK help us. Looks like 4 ninths, 25. Is that true? By just directly doing it. Now, the reason I did this, and I'm gonna take his concern here, I'm gonna redo it, and now let you be something, and redo it and see if it's a little bit easier. Go for it.
I mean, it can be just much easier if we just factor in the original one. 3x equals 3 root x times root x, and the tan equals, negative tan equals positive 2 times negative 5.
You break those numbers down into factors, yes, and it may end up at the same thing she finally ended up with. I understand that. But now let me go back to this. Let's redo the problem. And then appreciate doing it this way, not this way. What would you let u be in this case?
Square root x.
Square root x. Square root x, this middle, in that middle term there. If I do, I know and you know this first term can be that square root x that was given to me squared. Is square root x squared x. And therefore with that square root x now, that's the u, this becomes, look at this, how cute, 3u squared minus 13u subtract 10 equals 0. This one's doable. This one, I think we all could sit there and factor. Look at this mess down here I asked PK factor for us. What a mess. 229? This was much easier even at this point in terms of the u. Now watch me mess it up. I hope not. Okay, 3u. You guys help me out here, what? Maybe minus 5 here, I think, plus 2 here. You guys agree with the factors? Is it a factor? And then over here, this is u. So you got 3u plus 2 equal to 0. And u subtract 5 is equal to 0. I'm going to get the easy one out of the way. This one, of course, if you solve it, is a negative 2/3. Woo! Now, am I finished? No, this is u. We had u representing what? Square root x. You say, wait, Professor, you're not quite finished. I asked you to solve for x, not u. So this is square root x equals this. And square root x is equal to 5. Square both sides here. You quickly end up with x is equal to 25 pk. That was one of the answers you did the other way. But true? Now though, can someone tell me though, something we have to be cautious with? You say, Professor, go ahead and square both sides here, and you'll get the other number 4 ninths that she had. Anyone tell me what I should be cautious about on the other right here? Why should I not jump in and square both sides because it's so tempting? If I tell thee, stay away from that, we may not be able to use that 4 ninths she gave you earlier, Professor. Can you tell me why? Just looking at this. Go for it.
Because that would make the square root a negative.
Yeah, how on earth are you going to take the square root of something and get a negative answer? Even before you square both sides. That makes no sense. You can't do the square root and end up with a negative answer. So this has got to be rejected. Therefore, this is rejected. Therefore, now the only answer is 25. You understand the logic behind it? Now, please tell me with that we just worked it out. Now, do you get a full appreciation when you are able to do this? Lord knows, you don't want to do this. PK, you might. There's madness here. Much easier doing it this way and going, look how much easier it is up here compared to this. And guys, after all that work, look at all that work you took.
Answer is 25. And for goodness sake, hang on. Let me check this. Just 25. Guys, real quickly, replace 25 here, 3 times 25 in the original is 75. Put a 25 underneath that square root. Square root of 25 is 5 times 13, I think that's 65. And then minus 10. Will that give me 0 altogether? If it does, then I will definitely accept that answer of 25. It checks. This has got to be rejected because of that square root. Any concerns there, guys? So that's one there. I solved. Got one. Be careful here. Now, here goes. The next one. I think it's an n raised to the 6, is it? Or x, no, x. N of x. N of x. Yeah, x has been raised to the 6. Plus 7x cubed. Subtract 8. Now we'll do this with patience. Patience. If I have any student in this class, right now at this moment, who can within the next couple of minutes get all 6 answers, you've got to keep in mind that degree tells you how many answers to get. If I have any student in this class who can get all 6 answers within a couple of minutes, you're exempt from the exam on Friday. Stay home. Or come to the door and smile at the rest of us and wave at us. Any ideas? Oh. Wouldn't that be nice to be exempt from the test? You gotta get 6 answers. By the way, there's no square root involved here, thank goodness. I should get all 6. Nothing has to be rejected. Well, I'd be happy if you just get 2 of the 6. You just get 2, we're not going to exempt you from the test, but you got 2? You got,
No,
you got 2?
no, I got,
Yeah, you got 2 answers.
yes,
Okay. Where's the other 4?
no.
No, she said, Professor, don't go there. I'm not getting the other 4. She got 2 of them. You still have to take the test. I'm going to put someone to get all 6. I don't think as a student I would be able to do it. You get all 6 answers. By the way, is this also one of those where it says let you be something? At least that's where you help. Guys, I think we all recognize, I hope at this point, that u be x cubed. And why? Because this right here could be expressed as x cubed squared. And therefore that first term could be written, since u is representing x cubed, this is u squared, plus 7u, subtract 8, is equal to 0. Well, that looks pretty good. I think it factors. Make sure I factor correctly. Split this up. So far, so good. Some of my students may have gotten down to this point. Serena is telling me she thinks she got down to that point. That's the u. And what was u representing? X cubed. So you say, wait, Professor, not quite finished. This says x cubed is equal to -8. And x cubed is equal to 1. I love that u substitution. Pays off it. Makes work much easier. Now, can anyone tell me x cubed is equal to a -8? Can anyone tell me what x is? Yes?
-2.
It's gotta be. A -2 times a -2 times a -2 is -8. That's a cube root. On the other side it says x cubed is equal to 1. That one's more obvious. The answer's gotta be 1. Now we list. We have right now -2, 1. Marina, did you get those 2? Did any other student get those 2?
Okay, now, let me do this. This is where you would have been exempt. There are 4 more. When you finally have a quiz or an exam on this, and this is not on your exam on Friday, think of this. When you finally see it on the exam, and I have a 10 here, you cannot leave the classroom until you get 10 zeros. 10 answers. 12, you gotta get 12 zeros. Good luck. I had to get 6 here, so there are 4 missing. We may not do it all today. Does anyone have any idea how to find any of those 4 missing zeros? Anything at all? Go for it.
I know that besides the x, well, because you know you have the first 2 years, I know that besides x plus 2, x minus 1, you have to multiply by 2 other quadrants. But that there's like x or x squared something.
Oh, yeah, there's an x squared in there involved. I got you.
2x squared, like 2 different.
Oh, 2 different ones.
Yeah, I did a homework on this one.
Was that one of the homework problems?
Yes.
Whoa! He says he's already tried this, and he's sort of solved what to do here. But guys, we're missing 4 zeros. I don't know whether I'm gonna get into all the details here on this one or not. Let me just give you an idea of how to find a couple of those 4. And then I think you find the others yourself. You say, Professor, I had to find 6? Whatever this is. That degree tells you how many zeros to expect. I'm expecting 6. Now the sad thing is, the remaining 4 may involve i's, imaginary numbers. We don't know yet, they may involve i's. Now how am I gonna find them? You guys wanna just get you started on this and then I'll just pretty soon stop. Let's consider this one, where x cubed is equal to 1. You guys quickly said, Professor, x is 1. Yes. Could I have thought of this though, at this point, as looking like this? Are these two actually saying the same thing? I just move the 1 over. Okay. Now I made the x cubed minus 1, I just rewrote it, into a form that looks like this. Let me see how many students may recall. This takes the form of this. Are you kidding? A cubed subtract b cubed. X is a, b is 1. A cubed minus b cubed. Step back and look at it. Now before I jump into it, if it had come out to be this, which it didn't, because it has a cube. If it looked like this, every student in class would say, Professor, that's this. That's the difference of squares, they call it, back in algebra. Professor, that's that. A subtract b times a plus b. This one, where is it? A cubed minus b cubed. I don't know, I'm gonna stop at this point. But can anyone recall what a difference of cubes looks like? And I know you've seen it, you've probably forgotten. Not difference of squares. I wish it had been this myself. No, a difference of cubes. Does anyone think they recall how to factor a difference of cubes? And there was something given to you somewhere. Anyone recall what it was? No one's gonna be exempt from the test. I'll have a full class on Friday, which I love.
A minus B.
Oh, wait, hold on, somebody saying something? Who's saying that? PK, hang on. She says, Professor, it's not as easily done as this one, but she says, I think I've seen it before. It's A subtract B. PK, tell me more.
A squared
What? A squared.
plus
Do it again.
plus
Plus
AB
AB
plus
plus
B squared.
when we take the exam on Friday, I'm gonna isolate her. I gotta move her somewhere else so you guys, She has all this. Now, if you should multiply that out that she gave, she remembers it's like a formula. It's right in your textbook. It's like a formula for a difference of cubes. Guys, if you should be patient and multiply all this business out like in algebra, she tells me, Professor, let's just take it back to this. Now, if that's the formula, and I won't accept that as my formula. Mr. Park, is that the formula for the difference of cubes? June, is that is right? Look at that, PK knew it. Now, if I apply here, then we'll stop. Where am I gonna apply it? I'm gonna apply it on x cubed minus 1, her formula. So guys, this would look like this applying her formula. PK, I'm gonna give her a name to this formula. This is PK's formula. X subtract 1, x squared, plus 1 times x, x, plus 1 squared, which is 1. Oh my goodness. Let me make sure I put all that in there correctly. That's her red formula applied to this. You get this, which looks much like this. That's the formula I was using. True? And then you set each one of those equal to 0. You say, wait, Professor, you set this factor equal to 0. I think it takes you right back to 1 that we said should exist earlier. It does. This right here will give you 2 more answers. This is a quadratic. It'll give you 2 more of those 6 answers. You have to use quadratic formula. It's not a factor. I'll tell you that much. You have to use quadratic formula. And I think you end up with some I's coming in. So guys, I'm not going to finish that up today, but that's what's going on with those 6 zeros. You're hoping when you finally see this, Professor, please be kind. Don't put an 8 there, Professor. Or a 10. I'll be here all day trying to find those zeros. So stop me at this point and I'll finally get all this worked out. I'm not ready for pushing. We'll do this later on. Now, this is a gift. Take advantage of this gift tonight. So when I sit down and start scoring the papers, I had better see a 10, a 10, a 10, a 10, a 10, and maybe one